a general goal of allocating the resources you have for public programs efficiently. In order to do this, ideally, you'd look at all the programs, figure out how well they work, how much benefits they create, and then you'd pick the ones that work the best. Or, I'll say, the least badly, depending on context. Now, there's a fundamental problem here in that the way people usually go about this is to say, well, let's try something and see what happens. Well, then we only have the universe in which that thing was actually tried. And then we say, well, what do we actually compare that to? How do we construct a world where everything is the same except for that one thing where we never tried that particular program? Economists call this the construction of a counterfactual. Lawyers call it a but-for scenario, meaning everything is the same but for that one program. And it's very important to establish some sort of baseline as a point of comparison in order to truly observe the causal impact of a particular program. In other words, the problem that we face is that we generally only observe correlations, but correlation does not imply causation. You can see in this example here, this little cartoon, which is one of my favorites, by the way. So, I used to think correlation implied causation. Then I took a statistics course. Now it's all cleared up for me. Now here, the joke is that the fact that your confusion was alleviated after you took the course must have been because your confusion was alleviated because you took the course. And you can't really make that jump. In legal terms, the fallacy is referred to as post hoc ergo propter hoc. Because one thing happened after another, one thing must have happened because of the other. And we want to be very careful about not letting this type of fallacy get into our judgments about program effectiveness. Because when we see a correlation between two things, or when we see one thing happen after another, there are actually three possibilities. You can illustrate with this with a very simple example. Now, it's pretty common that you might see me carrying an umbrella when it's raining out. So those two events go together, umbrella and rain. You can think about, well, what is the causal mechanism that's actually going on there? Technically speaking, we have three possibilities. Could be that me carrying the umbrella caused it to rain. Doesn't seem very intuitive, but logically speaking, it's still in the running as a possibility. It could be the case that the rain caused me to carry the umbrella. So, okay, maybe intuitively that sounds a little bit more reasonable. There's also a third option, namely that some outside factor caused both the carrying of the umbrella and the rain. If we think a little bit creatively, you can start thinking about, well, what could that outside factor be? Would it be a weather report? A weather report might cause me to carry the umbrella. The weather report wouldn't literally cause rain. However, we could take that one step back and say, whatever caused the weather report ultimately caused me both to carry the umbrella and cause it to rain. So in order to really get at some causal impact calculation, we need to be able to distinguish among these three possibilities. Unfortunately, when we're faced with a situation where the answer seems intuitively appealing or intuitively obvious, we're not very good about going through the steps of explicitly questioning assumptions and questioning this chain of causality. For example, if we look at empirical data, we see that there is in fact a positive correlation between a parent's income and their children's SAT scores. So, in other words, richer parents have kids who do better on standardized tests. So, well, this isn't particularly surprising, but this sort of data is used to form conclusions such as, well, if we only gave more money or subsidized education for lower income parents, their children would achieve the same outcomes as the higher income parents. And in other words, we'll take correlation data such as this to infer that somehow money or the income must be causing the higher educational achievement. We don't question that because we say, yeah, that seems intuitively reasonable. However, when presented with a similar situation that is almost exactly the same in terms of setup, in terms of logic, but a different context, we reach a very different conclusion. And the correlation versus causation trigger in our brain goes off a little bit. So consider a very similar situation. Looks almost the same. One of my professors pointed this out, and I think it's an extremely good example of this type of fallacy in reasoning. Because if we were to look at empirical data, I haven't done the first-hand field research on this, but it stands to reason that there should also be a positive correlation between the number of bathrooms in a parent's house and the child's SAT score. Simply because higher income parents tend to have bigger houses, and bigger houses tend to have more bathrooms. So logically, this should follow from the previous graph. However, if I were then to tell you, if you want your child to do better on standardized tests, hire a contractor and install an extra bathroom in your house, you probably wouldn't take my advice on face value. But logically speaking, that was the same inference that we just made in the first case. So we need to be very careful about not being too easy on those conclusions that are intuitively appealing and subject them all to the same level of questioning and rigor. So how do we go about identifying true causal impact? Well, luckily, a lot of what you need to know you probably learned in elementary school. Because one approach is what I'll call the middle school science project. Now I remember when I was younger, go through, design a scientific experiment, you get to put everything on a board and you get judged, maybe you win an award for things. And I remember my research question was whether ants strictly prefer real sugar to artificial sugar. Like, can they actually tell the difference? And using the scientific method, you can actually set up a control in an experimental group. Find two anthills that look reasonably the same in the same location, put sugar near one, put the artificial sweetener near the other, and record the differences. And this is, in fact, at the heart of the scientific method. Because what we're doing is we're establishing a control group and then establishing an experimental group where only one thing has been changed. Therefore, if we observe a difference in outcome, we can pretty safely conclude that that difference is due to that one thing that we changed. We can actually go and do this in a very real sense out in the field. To say, we can run an experiment about particular social programs with a control group and an experimental group and observe those differences. And this is something that economists have actually started doing, particularly in developing countries. Esther Duflo at MIT runs a number of experiments in Kenya, some of them I believe in India, other developing countries, to look at the effects of incentives and policy changes on things like adoption of malaria bed nets, of getting immunizations for children, things like that, and really taking this scientific approach to determine what works and what doesn't. Because the fact of the matter is that there are limited resources to put towards funding these programs in third world countries, and it stands to reason that we want to do what actually works. She actually has a TED Talk about this, and I definitely recommend that you check it out. Economists are very big on efficiency, big on figuring out what works, identifying these causal impacts, to such a degree that development economists have actually taken what these researchers know about the world and used it to establish their own nonprofits based on these findings. One such nonprofit is called TamTam, and it in fact does distribute bed nets in Africa in accordance with the principles that have, and the knowledge that has been gained from these sorts of experiments. So we're able to essentially do more with the same resources because we have that additional knowledge. Unfortunately, despite the fact that this sort of approach has become fairly commonplace in clinical trials for pharmaceuticals, for example, you see a lot of that going on. People don't really question the ethics of that so much. When assigned to problems of social policy, these types of approaches have yet to get complete societal acceptance. And there are a number of objections. either that the experiments are somehow unfair or immoral, or actually that they're somehow unnecessary, getting back to this correlation versus causation fallacy. For example, in New York City, the department that works on preventing homelessness started a program called Home Base that aids families and gives them resources, both monetary and otherwise, to try and stave off homelessness for people that are in danger of losing their houses. Their program was originally started such that they had a certain amount of funding. People would show up, they would get those resources, and then when they didn't have any more funding, people just couldn't apply for the program anymore. And they wanted to really answer the question, does this program work? So they changed their approach a little bit and said, for those people who apply, they're going to be randomized into a control group or a treatment group. The control group, depending on how you want to look at it, either the control group can be the group that's accepted into the program or the one that's rejected. The point is that you have one group of applicants that was randomly rejected from the program and then tracked, and another group of applicants who were accepted into the program and then tracked. And the question that the program wants to answer is, what is the difference in outcomes between these two groups? And compare that to the argument of one who thinks that this particular experiment is unnecessary, that's of the form, 90% of the families who received help from Home Base did not end up in homeless shelters. Well, that sounds fantastic. And again, intuitively speaking, you can say, well, how is this not a clear measure of success? But what you really don't know is the following. Was it really Home Base and the program itself that caused these people to not be homeless? Or was it something else, perhaps that these people who happened to apply were resourceful, that both caused them to apply for the program and caused them to not be homeless? In other words, if these people are resourceful, maybe they would have figured out how to avoid losing their house even without the support of this particular program. And what we really want to get at is, what is the particular impact that this program has above and beyond what people would have done anyway? In addition to these sorts of ethical questions, which hopefully will go away as these experiments become more commonplace and the need for them is better understood, we also have some practical considerations to take into account. Namely, that not every experiment can actually be performed. For example, if I wanted to try to estimate the effect of government stimulus programs on an economy, theoretically, I could say, okay, we're going to randomize the population into the stimulus and no stimulus group. The no stimulus people can only interact with other no stimulus people, because otherwise you get all the effects mixing together. This group can only interact with this group. That's not really a practical thing. To say, well, not every experiment that economists would ideally want to run in order to see a causal impact can actually be done. We also have the problem that we can't retroactively run experiments. That if we want to say what was the effect of something that was implemented 50 years ago, well, we can't really run an experiment 50 years ago until we invent a time machine, so we're sort of out of luck. Given these limitations and these considerations, economists need to be a little bit more creative about how to tease out these causal relationships. Because a lot of times all we have to deal with is what we'll call observational data. Meaning that rather than intervening in the world, all we can do is look at it, take notes, and see what's happening naturally. Again, we can only observe correlations. What we can do, however, is look for what economists call natural experiments. What this means is that even though the researcher, him or herself, can't actively separate participants into a control and experimental group, we can certainly look for ways in which nature does this for us. And it gets sort of, as a creative exercise, it gets pretty interesting. And economists have been able to use this technique in order to get some pretty interesting findings. For example, Professor Joshua Angrist at MIT, he wanted to understand the impact of military service on a person's lifetime earnings, particularly in the Vietnam War era, especially in those circumstances where soldiers weren't necessarily looked upon the way they should have when they came home, et cetera. I said, well, what impact is putting people in the military actually having? Because we need to understand that in order to be able to evaluate our policy choices in that area. Now, one approach would be to say, well, this seems pretty easy. Just look at the people who are in the military, look at the people who aren't, compare earnings. So, well, that's sort of a naive approach because maybe people who are in the military have different skills. Maybe they're going into different industries. Maybe they're older, younger, different levels of education. Okay, well, we can control for all of that. Basically, a researcher can control for whatever the researcher can see. So let's control for age. Let's control for education. Let's control for occupation, and so on and so forth. And then let's compare those groups of veterans and non-veterans. The problem is that those groups, under normal circumstances, are still usually not comparable, simply because there's something that the researcher can't see that's causing one person to choose to go into the military and the other person to choose not. Maybe a person knew that they needed the discipline that the military provides and they wouldn't be a good worker without it. Maybe they knew that they had more draft lottery in the United States and said, in that situation, rather than having people choose for themselves whether or not to embark on military service, we essentially had the government creating our control and experimental groups for us. Now we have a situation where people actually are comparable. The only difference is that one person got lucky and the other didn't. And we can more carefully say we have two comparable groups of people and we can compare those outcomes. And what Professor Angrist does in fact find is that there is about a 15% negative impact on lifetime earnings for white males who served in Vietnam because of the draft lottery. Now, it's a little bit questionable how generalizable those findings are, but at least for that particular context, that gives us a better estimate of a causal relationship than just looking at comparisons among groups who self-selected into those groups. In other words, what we're trying to differentiate here is whether the military service itself actually caused the lower earnings or whether it was some outside factor that caused both the military service and the difference in earnings. And he was actually able to establish that it was the condition on the left rather than the condition on the right. Study the impact of increased police presence on crime. Again, a hard question to answer, because is it really the case that more police reduces crime level? Is it the case that a reduced crime level causes more police? Doesn't really seem intuitively appealing, but I suppose it's technically possible. Or is it the case that some outside factor causes both the increased police presence and the reduced crime? And what Professor Levitt does is he looks at election cycles, because he noticed that at certain points in the election cycles, politicians who are interested in getting reelected would almost randomly say, oh, well, it's going to look good if I increase police presence. So for no reason related to crime itself, they'll increase the number of police officers. Economists call this exogenous variation. You can roughly think of that as an act of nature that's serving to randomize into these different treatment groups. And again, what he finds is that there actually is a causal relationship between increased police presence and reduced crime, because when we have police presence increasing for reasons that for our purposes are essentially random, it's closely followed by a reduction in the crime rate. For those of us that have embraced the scientific process, this is one way of getting at some sort of cause and effect and really being able to see which programs and which policies can most effectively and efficiently make our world a better place. Thank you.